Using the example 2x plus 5y equals negative 5 and x plus 3y equals 3, we are going to solve the linear system with the substitution method by starting with step 1, which is to solve one of the equations for one of its variables. By doing this, we are going to use x plus 3y equals 3. We are going to subtract the 3y from the left side and move it to the right, which will give you the equation of x equals negative 3y plus 3. For step 2, you need to substitute the expression from step 1 into the other equation and solve for the other variable, which means we will take the equation 2x plus 5y equals negative 5 and substitute the x equals negative 3y plus 3 into the 2x spot by putting the negative 3y plus 3 where the x would be in the equation. Then you will substitute the 2 into the parentheses of negative 3y plus 3. Then you should combine like terms. Once you do that, you should take the 6 and subtract it from the left side and do the same onto the right side. Then you should divide negative y1 by negative 1 and do the same for the right side, which should then give you the answer of y equals 11. Step 3 for substitution method states that you should substitute the value from step 2 into the revised equation from step 1 and solve. So this means you will take the equation x equals negative 3y plus 3 and add the y equals 11 into the negative 3y spot, which will then look like x equals negative 3 parentheses 11 plus 3. You then need to distribute the negative 3 into the parentheses, which will then give you negative 33. Then you need to combine the like terms, which gives you the answer of x equals negative 30. So then your solution would be negative 30, 11. To check to see if your answer is right, you need to substitute your answer into the original equations. So to do this, you will place the x and y values that you got as your solution, which would be negative 30 and 11, into the equation of 2x plus 5y equals negative 5, and do the same for the x plus 3, y equals 3. To solve, you will distribute through to the parentheses, and then if your answer is correct, you will know because it will be equal on both sides. Because the original equations are still true with your solution added in, it shows that your solution is in fact correct, due to 3 equals 3 and negative 5 does in fact equal negative 5.
Alright! To use the elimination method to solve linear problems algebraically. Step 1. Multiply one or both of the equations by a constant to obtain coefficients that differ only in sign for one of the variables. And for the example here, we have 3x minus 7y equals 10, and 6x minus 8y equals 8. So for step 1, multiply equation, you would multiply the equation 1, so this 3x minus 7y equals 10, by negative 2, so that the coefficients of x differ only in sign. So there, as you see, I have negative 2 times 3x minus 7y equals 10, and then the second equation, 6x minus 8y equals 8, stays the same. But if so negative 2 times 3 is negative 6x, let me put that. So as you can see, it's negative 6 minus 7y. Now that's only the first step, which is multiply one or both of the equations by a constant to obtain coefficients that differ only in sign for one of the variables. And as you can see, I only did the one problem. I only took the one equation. Step 2 is to add the revised equations from step 1. Combining like terms will eliminate one of the variables. Solve for the remaining variable. Now what that means is to add the revised equations and solve for y. So let's say I add these equations. X would cancel out. So if I were to add them together, X would cancel out, like I will show you. So as you can see, there's the 0x plus 6y equals negative 12. Now you're probably wondering, well, whoa. Oops, my bad. Let me think about that for a second. I forgot to take the negative 2 times 7, and I will go do that now. So now we have negative 6x plus 14y equals 10. Only because we took the negative 2 times both of them. So if we add them together, and the x will cross out, so we have 0x plus 6y equals negative 12. But you don't really need the 0. So it'd really be 6y equals, so if you can see at the very bottom there, 6y equals negative 12. So, how to solve for y? You divide both sides by 6. So if you divide by 6, you would end up getting y equals negative 2. So there's your step 2. So now let's go on to step 3. Substitute the value obtained in step 2 into either of the original equations and solve for the other variable. So what that really means is substitute the value of y into one of the original equations and solve for x. So let's use the first one, 3x minus 7y equals 10. So if I write that at the bottom, so now we have the original equation we plan to use. Now we just need to plug in the negative y equals negative 2 into the equation, like so. So now as you can see, the y changed to a negative 2. So then after we substituted the negative 2 for the y, we're going to solve for 7 times negative 2, which is 4. Still with me? Now we gotta figure out x. So, long story short, we'd have to subtract 14 from both sides, and then divide by 3, which gives us x being negative 4. So with x equaling negative 4/3, because we subtract 14 divided by 3, our solution has to be an ordered pair. So it would be negative 4/3, like this thing here, and negative 2. So we'd write it like an ordered pair. So then, as you can see at the bottom, we have negative 4/3, comma, negative 2. So that's your solution there. So there, solution equals negative, because you put your negative 4/3 from when you plug the y into the first equation, and you got the y equals negative 2 by subtracting the two equations. And basically, now to check it, you can check it by substituting the numbers into the variables into the original equations. What I mean by that is taking the first equation again and plugging both of these numbers in. Or we can take the second equation, but I'm going to take the first one. So if you look over to the right here, I have 3 times negative 4/3 minus 7 times negative 2 equals 10. So if we were to multiply all this, 3 times negative 7 times negative 2 is 14, like we've said before. But 3 times negative 4/3 would be, so there, I have negative 4 plus 14 equals 10. And I did it because I cross-canceled the 3's. And so there's my check. And so let's add the negative 4 and 14. So negative plus positive. So there, as you can see, I cross-cancel the 3's, making them 1's. So negative 4 over 1 makes it negative 4, so negative 4 plus 14 equals 10. 14 minus 4 equals 10.
These are the instructions on how to solve linear systems with many or no solutions. These are the instructions on how to find the coordinates of the point of intersection. Your homework for tonight is page 164 to 165, numbers 6 through 21, multiples of 3, 27 through 36, multiples of 3, and number 42.